5.1 is solving systems of linear equations by graphing. With these systems of equations are literally two or more equations that are given to you, and their solution is the ordered pair, so an x value and a y value, that make each of the statements or each of the equations true statements. So there's different ways of doing these. The way that we're going to be going over it today is by graphing. So you'll graph both of these lines on a coordinate plane, and wherever these two lines intersect, that ordered pair, where they intersect, is your solution. The first part that we're going to look at is checking solutions. So we're telling whether the ordered pair that's given to us is a solution to the system. So if we look at example 1a, we have x plus y is equal to 7, and 2x minus 3y is equal to negative 11. We have the ordered pair 2, 5. We are going to substitute in that 2 for x and that 5 for y in both of these equations and see if we get true statements. If we get true statements for both of the equations, then the 2, 5 is a solution. So if we take the 2, substitute in for x, and x plus y is equal to 7, we're going to get 2 plus y, which is 5, is equal to 7. The 2 plus 5 is 7. 7 is equal to 7, so that one is true. Try the 2x minus 3y is equal to negative 11 now. So if we plug in that 2 for x, we're going to have 2 times 2 minus 3 times y, which is 5, is equal to negative 11. The 2 times 2 gives us 4. The negative 3 times 5 is negative 15. The 4 minus 15 gives us negative 11, and that is equal to negative 11. So that 2, 5 is a solution. If we look at example B, we have y minus 2x is equal to 4 and y is equal to negative 2x minus 4 and y is equal to x plus 4 with the ordered pair negative 2, 0. So with this, we're going to plug these in. So we're going to have 0 is equal to negative 2 times negative 2 minus 4, as well as 0 is equal to 2 plus 4. That negative 2 times negative 2 is 4. So we have 0 is equal to 4 minus 4. The 4 minus 4 is 0. So 0 is equal to 0. That's a true statement. For the other equation, though, you have 0 is equal to negative 2 plus 4. The negative 2 plus 4 gives us 2. So 0 is equal to 2. This is a false statement. So because both of these are not true statements, that negative 2, 0 is not a solution. For example C, we're given 2x plus y is equal to 0. And negative x plus 2y is equal to 5 with the ordered pair 1, negative 2. So I'm going to plug in the 1 for x and the negative 2 for y. This is going to give me 2 times 1 plus negative 2 is equal to 0, as well as a negative, or the opposite of 1, plus 2 times negative 2 is equal to 5. 2 times 1 with the equation on the left gives us 2. Plus a negative 2 is 2 minus 2 is equal to 0. This gives us 0 is equal to 0. This, in fact, is correct. So solve the other. You have a negative, or the opposite of 1. So that's negative 1. Plus 2 times negative 2, which is negative 5, is equal to 5. Negative 4 is equal to 5. The negative 1 minus 4 is negative 5, is equal to negative 5. Again, we do not have a true statement here, so both of these are not true. So 1, negative 2 is not a solution. For example D, we have y is equal to 3x plus 1 and y is equal to negative x plus 5 with the ordered pair 1, 4. So this is going to give us 4 is equal to 3 times 1 plus 1 and 4 is equal to the opposite of 1 plus 5. The 3 times 1 is 3, so that's 4 is equal to 3 plus 1. This simplifies to be 4 is equal to 4. That is a true statement. For the 4 is equal to -1 plus 5. -1 plus 5 is 4. 4 is equal to 4. That as well is a true statement. So our 1, 4 is a solution. So for the part that is really important with this is to graph these equations and see where these two lines intersect. Where these two lines intersect will be your solution for the system of equations. If we look at example A, we are given y is equal to -2x plus 5 and y is equal to 4x minus 1. Now you see both of these equations are in slope-intercept form, so we do not need to rearrange terms or move anything in order to solve the equation for y for either one of these. We can identify our slope and our y-intercept in order to graph each of these lines and extend our lines throughout the entire coordinate plane to get the exact point at which these two lines intersect. So if we look at the first one, that y is equal to -2x plus 5, this is giving us a slope of -2 and a y-intercept or a b value of 5. So on our y-axis, we're going to plot our first point at 5. From there, we're going to go down 2 and to the right 1. And I'm going to continue doing this throughout my entire coordinate plane. And I'm going to go up 2 into the left 1 as well. So my line, again, goes through my entire coordinate plane. For my second line, I have y is equal to 4x minus 1. So a slope of this one of 4 and a y-intercept b value of -1. So at my -1 on my y-axis, I'm going to plot my first point. From there, I'm going to go up 4 to the right 1. Up 4 to the right 1. I'm also going to go down 4 and to the left 1 to go through my entire coordinate plane. So from here, I can draw my line through these points and identify the point in which these two lines intersect. So where these two lines intersect is this point here. So that point is 1, 3. My solution of this system is the ordered pair 1, 3. For example B, we're given y is equal to x minus 2 and y is equal to -x plus 4. For the first equation, we have a slope of 1 and a b value of -2. So we're going to plot our first point at that -2, and our slope is 1. So we're going to go up 1 to the right 1 and go the entire distance of this coordinate plane. We're also going to go down 1 into the left 1 in the opposite direction to get those points to the left of that y-intercept. So once we have all of those points, we draw a line through them. And we move on to graphing that second line. So the second line we have is y is equal to -x plus 4. So our slope for this one is -1. Our b value is 4. So we're going to have 4 on the y-axis. Then we're going to go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. You're also going to go up 1 into the left 1, so that way you get that line throughout the entire coordinate plane. And then draw your line through your points. Now that both of your lines are drawn on this coordinate plane, see where they intersect. The point in which they intersect is this one here. So that is the ordered pair 3, 1. So your solution to this system of equations is 3, 1. For example C, we have y is equal to 1/2 x plus 3, and y is equal to -3/2x minus 5. Once again, these are both in slope-intercept form, so identify your y-intercept and your slope, plot the y-intercept, use your slope to get your next points. For the first one, that y is equal to 1/2 x plus 3, our slope is 1/2, our b value is 3. So on that y-axis, we're going to plot our first point at 3, and then we're going to go up 1 to the right 2, up 1 to the right 2. Keep it going the entire way, and then go the opposite direction. So instead of going up, we're going to go down. Instead of going to the right, we're going to go left. So down 1 to the left 2, down 1 to the left 2. Draw your line through those points, and then move to your second line. Your second line, you have y is equal to -3/2x minus 5. So our y-intercept is our slope is -3/2, and our b value is -5. So at -5, we plot that first point. From there, we're going to go down 3 and to the right 2. Down 3 to the right 2. We're also going to go up 3 to the left 2. And then we plot we draw our line through these plotted points. So now look to see where those two lines cross. We have an intersection here. So that ordered pair, that's our solution, is -4, 1. For example D, we're given 2x plus y is equal to 5, and 3x minus 2y is equal to 4. Neither of these equations are in slope-intercept form, so the easiest way to graph them is to put them in slope-intercept form, identify your slope, your y-intercept, plot the y-intercept, use your slope to get your next points. So for the first one, that 2x plus y is equal to 5, I would just move the 2x over by subtracting it from each side, and I'd be left with y is equal to -2x plus 5. So for this one, I have a slope of -2 and a y-intercept value for b of 5. So on my y-axis, I plot my first point at 5, and then I'm going to go down 2 to the right 1, down 2 to the right 1. Keep it going the entire coordinate plane and also in the opposite direction. So we're going to go up 2 to the left 1, up 2 to the left 1. Once I have all my points, I'm going to draw my line through them and move on to solving my other equation for y. My second line is that 3x minus 2y is equal to 4. I'm going to start this one by subtracting the 3x from each side. We have -2y is equal to -3x plus 4. And then we divide each side by that -2, which means everything on that right side gets divided by that -2. So we have y is equal to 3/2x minus 2. For this one, we have a slope of 3/2 and a b value of -2. So on our y-axis, we're going to plot the first point at -2. Then from there, we're going to go up 3 to the right 2, up 3 to the right 2. We're also going to go down 3 to the left 2. And then we plot our or draw our line through those plotted points. So then we look further where those two lines intersect. We have the ordered pair of 2, 1. That's our solution.